Now we see from this representation there is no x which is both greater than minus 3 by 2 and less than minus 1.5. Now multiplying both sides by minus 1 we get 2x minus 1 by x plus 1. This one will be reversed. Let me discuss the second one. We have to first simplify the denominator. X by 3x minus 3 plus 2x plus 10 greater than 3, or x by 5x plus 7 minus 3 greater than 0, or x minus 15x minus 21 divided by 5x plus 7 or minus 14x minus 21 divided by 5x plus 7 greater than 0. Now both are negative. Minus 14x minus 21. If we want positive one, that means we are multiplying that minus by minus 1 on both sides, then the inequality sign will be reversed. Also 7 is common factor here. I have multiplied both both sides of the inequality by minus 1. This inequality sign is reversed, or 2x plus 3 by 5x plus 7 is less than 0. Divided both sides by 7, which is positive, therefore no change of the inequality symbol. Now we see the fraction is negative, therefore first case two x plus 3 positive, 5x plus 7 negative. Second case 2x plus 3 less than 0, 5x plus 7 greater than 0. Now we discuss these two separately. From here we are getting 2x greater than minus 3, therefore x greater than minus 3 by 2. From here 5x less than minus 7, therefore x less than minus 7 by 5. This is minus 1.5 and this is equal to minus 1.4. Greater than minus 1.5 and this is less than minus 1.4. Therefore, we can combine these two. Minus 3 by 2 less than and from this 2x less than minus 3, from that x less than minus 3 by 2, and 5x greater than minus 7, from that x greater than minus 7 by 5. Now you cannot find a x which will satisfy both these two. Therefore, from this one we are not getting any value of x. That means this is impossible. Which is impossible? You can take help of the number line here. X less than minus 3 by 2. If I (1.5) minus 1.5, x equal to minus 1.5, then 1.4, 1.5, then in x is less than minus 3 by 2, and for this one now we see from this representation there is no x which is both greater than minus 3 by 2 and less than minus 1.5. Therefore, this is quite impossible. So finally, we get this one. Therefore, if we require to express that solution, then you rub these two, and within the interval minus 3 by 2, minus 7 by 5, that will be the solution set. Now we move to the next problem. First one is this. Three by modulus of x plus 1 greater than 2. First you note that modulus of x plus 1 is at the denominator. Now denominator and the numerator is constant. Therefore denominator involves variable, but denominator cannot be 0. Therefore we first consider x plus 1 where x is not equal to minus 1. Now x equal to minus 1 divides the whole number line into two parts. We have to consider those two parts. Since others are constant, therefore we consider those two. When x less than minus 1, modulus of x plus 1 will be minus x minus 1. We call this as 1 from 1 minus 3 by minus x minus 1 greater than 2, or 3 by now I multiply by minus 1 so that this inequality symbol will be reversed, or 3 by x plus 1 plus 2 less than 0. Now we simplify 3 plus 2x plus 2 by x plus 1 less than 0, or 2x plus 5 by x plus 1 less than 0. Now you see the fraction is negative and both numerator and denominator involve x. Already I have discussed, if the fraction be negative, then there arise two cases. First case, first case numerator positive, denominator negative. Second case numerator negative, denominator positive. Therefore, I write here, first case 2x plus 5 positive, x plus 1 negative. Second case 2x plus 5 negative, x plus 1 positive. Now we solve these two first, or 2x greater than minus 5, therefore x greater than minus 5 by 2. From here, x less than minus 1. This is actually x greater than minus 2.5 and x less than minus 1. Therefore, the interval will be and if we solve these two, x less than minus 5 by 2, x greater than minus 1, which is not possible for a single x. Single x cannot satisfy both these two. Therefore, this is impossible case. Therefore, required solution or solution set X belongs to we can also represent the solution set on the number line as we have done earlier. Actually, I have considered here this one, that is why the solution set is this one. Now we have to consider the other case. When x greater than minus 1. In that case, modulus of x plus 1 will be x plus 1. Therefore, from 1 we are getting 3 by x plus 1 greater than 2. I write on the right side 3 by x plus 1 minus 2 greater than 0, or 3 minus 2x minus 2 whole by x plus 1 positive, or minus 2x plus 1 by x plus 1, that is positive. Now multiplying both sides by minus 1, we get 2x minus 1 by x plus 1. This one will be reversed. Now we have to consider these cases. I draw there. Fraction is negative, therefore I take first case like this, 2x minus 1 positive, numerator positive, denominator negative. Second case, 2x minus 1 less than 0, x plus 1 greater than 0. Now from this what we get? Or 2x greater than 1, from that x greater than half, and from here x less than minus 1. Now this is not possible. X is greater than half, simultaneously x is less than minus 1, impossible. I make the comment here. And from it, or 2x less than 1, therefore x less than half, and from here x greater than minus 1. Now minus 1 less than x less than half. Therefore, this is another solution set. Therefore, finally, required solution set will be this union therefore, finally, solution set is this one. We have to consider both cases. X plus 1 less than 0 case and x plus 1 greater than 0 case, and discussing both the cases we get required solution set. Now this sum, fraction form, numerator is mod x minus 5, denominator is mod x minus 3, fraction is positive. Here mod x minus 3 is not equal to 0, means mod x not equal to 3, that is x is not equal to plus minus 3. My suggestion is that when you get such fraction form, first you mention the denominator not equal to 0. Now we see x is not equal to plus minus 3 and the fraction is positive. Both numerator denominator positive. First, consider the first case. From here, mod x greater than 5, therefore x greater than 5 when x positive and x when x negative, that means modulus of x will be minus x. Minus x greater than 5. Therefore, we get x greater than 5, also x less than minus 5. Which is not possible simultaneously by any x greater than 5 as well as minus less than minus 5. Now from this, modulus x greater than 3 or x greater than 3 when x positive, minus x greater than 3 when x negative. From this, what we get? X less than minus 3. X greater than 3, x less than minus 3, not possible. Then we consider the second case. Fraction positive, therefore both numerator and denominator will be negative. Now from this, what we get? Mod x less than 5, therefore x less than 5 when x positive, minus x less than 5 when x negative. From it we get, from this, x less than minus 5. X less than 5, it will be reversed, x greater than minus 5. Therefore, combination of these two will be minus 5 less than x less than 5. And from it, x less than 3 when x positive, minus x less than 3 when x negative. From this we get x less than minus, so x greater than minus 3. Therefore, from it we get minus 3 less than x less than 3. Now we get two intervals. What is the common interval? Here x greater than minus 5, here x greater than minus 3. Therefore, common region will be this one, minus 3 less than x less than 3, minus x less than from the first part what we have got, minus infinity less than minus 5, and from here we have got less than minus 5 to infinity. From here x less than, this will be the simultaneously x less than minus 5, x less than minus 3. This is solution region. From these two, this is the solution region, and from this one, solution region is common solution region is minus 3 less than x less than 3. 5 to infinity. 5 to infinity. Less than 5. Actually, from the first case, we see modulus x greater than 5, modulus x greater than 3. That means common solution will be obtained, solution region will be obtained from this one, and this one is and from these two, or from the second case, we see mod x less than 5, mod x less than 3, we shall get the common solution region, this one. Thus, these two is the common solution region. Finally, we write required solution x belongs to minus infinity to minus 5. Now, this lies in between these two. If we plot on the number line, we find when we, I repeat actually, when we consider the first case, we first note mod x greater than 5, mod x greater than 3. From that, solution region will be actually common for this case minus infinity to minus 5, 5 to infinity. Union of these two intervals. And for the second case, mod x less than 5 here, mod x less than 3. Then region will be mod x less than 3. From that we get this. Now we have to combine these two for the required solution. Therefore, finally required solution is this one. Now this sum modulus of x plus 1 by x greater than 2. Now we have to consider two cases. Then in that case modulus will be positive, that is x plus 1 by x greater than 2. Now if we simplify this, we get x square plus 1 by x positive. X square plus 1 is positive. From that, this x is positive. X square plus 1, x square number, that is non-negative. X square plus 1, that will be always greater than equal to 1. Therefore, to be positive this fraction, denominator must be positive. This is the case. Now, we simplify this. Already we know x greater than 0, therefore from that x minus 1 whole square greater than 0, therefore square number is positive, therefore that number may be positive or negative. From this, what we get, x greater than 1, and from this we get x less than 1. Now we have x positive, therefore from here x here you can mention sorry, not this one, greater than 1, that means 1 to infinity. Next we consider the other case when x plus 1 by x less than 0. That means if I call this as 1, or I take it on the right side. I have taken this one on the right side, or here x less than 0, and from here x not equal to minus 1. X plus 1 in this case will be positive, or x plus 1 negative, that means x is not equal to minus 1. Now from this we get x belongs to minus 1, 0, and here x not equal to 0, therefore x belongs to minus infinity, 0, 1, infinity. Also 0, 1 case. Note that minus infinity to 1 and x not equal to 0, therefore the region will be, or interval will be, minus infinity to 0, then 0 to 1 and 1 to infinity. 1 to infinity is there, therefore this, and from here x belongs to minus 1, 0 interval. Therefore finally solution x belongs to minus infinity to 0, union 0 to minus infinity to minus 1 rather, then minus 1 to 0, 0, 1, then 1 to infinity. First minus infinity to minus 1, then minus 1 to 0, then 0 to 1, 1 to infinity. Actually, if we express that minus infinity to 0, there is minus 1 to 0 also. That means solution region will be represented by that graphical representation on number line. This is x less than minus 1, this is minus 1 less than x less than 0, then this one 0 less than x less than 1, then this one. Finally, this is the solution. This can be represented also by set of reals minus set of reals minus set members having members minus 1, 0 and 1. That means this region.